So we're going to have this where it says a rock falling from the sky. So a rock is dropped from a 500-foot building, and a camera captures the rock falling down. Now, note that would be very dangerous, and that could, hurt someone really bad if they get hit by a rock from that distance. But our question here is, how far will the rock have fallen after 6 seconds? So if here we're at 0 seconds, it fell 0 feet, and at 1 second, it fell 16 feet. What I'm going to do is I notice that these second numbers are square numbers. So here, I could write 0 as 0 times 0, and 16 as 4 times 4. And at 2 seconds, 64 is 8 times 8. And at 3 seconds, 144 is 12 times 12. And 256, if I notice a pattern, I'm going 4, 8, 12. I'm wondering if 256 is 16 times 16. Now, I don't have that one memorized, so I'm just going to check that. 16 times 16. Yeah, that's 256. And then here at 5 seconds, we're at 20 times 20, which is 400. So at 6 seconds, this is going to be, if I extend this pattern for 6, it's going to be 24 times 24. Which is 576 feet. But the reality is the building is only 500 feet. So this, although theoretically the rock would have went that far, it would have hit the ground. So I'm going to put, but only 500 feet. Now, Jada noticed that these are all multiples of 16. So she noticed that at 1 second, we're at 16 times 1. And at 2 seconds, 64 is equal to 16 times, so if I take 64 and divide it by 16, it's 16 times 4. And for 3 seconds, if I take my 144 and divide it by 16, we get 9. So it's 9, or 16 times 9. And then for, I'm going to write these up here too. So in the first second, it was 16 times 1. And in the second it was 16 times 4. For the third, it was 16 times 9. And then here, 256 is 16 times, we saw that, 16. And then here, if I take 400 and divide it by 16, that is 16 times 25. Now, I'm noticing something. The first numbers are all multiples of 16, but these second numbers are all square numbers. So we have 1, 4, 9, 16, and 25. Well, I can write this as 16 times 1 to the second power, and 16 times 2 to the second power, and 16 times 3 to the second power, and 16 times 4 to the second power, and 16 times 5 to the second power. Well, this becomes a little bit more easy because what I notice is that this 16 is just constant. We have 16 all the time. And the second number is the number of seconds squared. So here, In Jada's way, to figure this out after 7 seconds, we would go 16 times 7 seconds to the second power. And then we can just put that in our calculator. 16 times 7 to the second power. And it would be 784 feet. So in general, for any equation to represent the distance after t seconds that it dropped, our distance would equal 16 and then times our time number to the second power. Now notice, this is a quadratic equation. Because we have t to the second power.